Okay, so I'm going to tell you what the second fundamental theorem of calculus is. It sounds like it's important since it's fundamental, but it's actually not too bad. Basically, it's combining integrals and derivatives together. So let's look at an example. The first couple examples, I'm going to kind of work it out for you, and then from there, we're going to actually do some problems. So let's say that we have something that says d dx, that stands for the derivative of the integral of 0 to 2 of dx. Well, let's solve it. What we're going to do first is this part right here. We're going to find the antiderivative. We're going to plug in 0 and 2 and subtract. Alright, the antiderivative would be x squared over 2. We need to evaluate it at 2 and 0. So that would be 2 squared over 2, 4 over 2, which is 2. Plug in 0, so you get 2 minus 0, so then you get 2. Now, at the beginning of the problem, it said take the derivative of that. It's saying take the derivative of what you get for the integral. Well, the derivative of that is 0. And that makes sense, because the thing inside of the parentheses is a number. Since it has numbers on the integral, I know I'm going to get a number and not an equation. And when I take the integral of a number, I get 0. So I really didn't have to work it out to see that. Okay, so this one's different because it has a t in the problem, so I'm not going to get just a number, so the answer is not just 0. So, but I'm going to start with this part here. Let's find the antiderivative. Plug in 1 and t. Subtract. So that's what I would get. And now this says take the derivative of that. So the derivative of that would be, alright, the derivative of t squared over 2, that would be the same as 1/2 t squared. Let's think about that. 1/2 t squared. So that would be 1t. And then the derivative of a half is 0, so you get t. What you should notice is that we kind of ended up back with what we started with, except there's a t in there. And that makes sense because we're taking the derivative of an integral. An integral gives you the original equation. And if you take the derivative of the original, you end back up with what you started with. The only difference here is because there was a t there, I had to put a t in the place of x. And that's basically what the formula says. If you want to take the derivative of an integral, you end back up with what you started with. That's basically the second fundamental theorem. Now, the process changes a little bit depending on what's here and what's here. If they're numbers, you get 0 like we did on the first example. If there's a letter on top, then you just take the letter and you plug it in and you get the equation. If there's letters on both of them, then you're going to do two separate things and subtract, just like you would with an integral. If there's a letter on the bottom, then it's going to be something minus something, and I'll show you all those types of examples. So if I want to take the derivative of this integral, I know I'm going to end up with what I start with. Looking at what I have here, I know I'm going to plug the t in for the x's, so I'm going to have t squared plus e to the t. And then if I plug the numbers in, then that wouldn't be correct because I'm taking the derivative of those numbers, so this is the answer. Think about if you found that antiderivative, and then you plugged in the t, and then you plugged in the 10, and then you take the derivative. The part where you would plug in the 10, that would give you 0, so the 10 doesn't really matter in this type of problem. Okay, we're taking the derivative of t with respect to t of sine x minus 2. Notice that the t is on the bottom. Okay, that part, I'm not going to plug in the 5. I know that part's going to give me 0. But because the t's on the bottom, that just means my answer is going to be negative. And then you just plug the t in. And it doesn't have a plus c because the derivative of c would be 0. So that plus c is not there. Alright, this one's a little different because the part that has the variable with it is not just a t. The only thing you have to do there is you have to consider that the derivative of that is something and work that into the problem. So I start off by plugging that into the equation for the x, but then I multiply by the derivative of whatever that is. So I multiply by 2. And then I'm not going to subtract anything because I know that that part would have been 0. So it's basically 2 over 2t minus 1. The only difference is I multiply by the derivative of that part of it. Same kind of problem. I plug in the sine of t, but then I multiply by the derivative of sine of t. And it doesn't matter what variables we use as long as, like on the problems we've been doing, the numbers I'm plugging in are t's, so it's the derivative of t's. Here that I'm plugging in x's, so it's the derivative with respect to x. Alright, notice that the e to the x is on the bottom. This part's going to give me 0, so I don't worry about it. So since that part's 0, we're going to plug in a negative and then plug in the e to the x. But then you multiply by the derivative of e to x. So you just multiply it by it once. So you get negative e to the x. I'm going to put that together. Whenever you're raising to powers, you multiply exponents, so that's e to the 2x minus 3e to the x. Alright, on this one, since there's x's on both parts of them, what you're going to do is them separately. So you start with the 4x and you plug it in for t. Multiply by its derivative. And then you subtract and you plug in the x and you multiply by the derivative of x, which is 1, so there's nothing to multiply there. And then you get your answer. The only reason you don't do this on the other problems is because you would be taking the derivative of a number, and so that's why you get 0. But since they both have x's, you plug each of them in and then subtract and take those derivatives at the time that you do those parts of it. Now, it might be written another way, and I just want to show you real quick. It might say, okay, big F of x is this, and it might say find big F prime of x. That just means find the derivative. So all you would do is the same as what we've been doing. You would plug in the x squared for t, and then you would multiply by the derivative of x squared. And then you don't plug in the negative 5 because the derivative of that would be 0. So you would get that. If you want to put the 2x in front, that would be great. then there's 3 problems for you to try. And when you try these, I want you to try them on a separate sheet.